In my server closet, I have two 24-port TP-Link switches. One of the switches has PoE, and one of the other ones does not have PoE. And for a while now, I've been wanting to kind of consolidate that to a single 48-port PoE switch. I also have run out of, with two 24-port switches, I actually have a third switch that I had a long time ago for that has PoE. That's only 8 ports, and so I grew out of that 8-port PoE switch pretty quick. That's why I got a 24-port. So that's why I ended up with 3 switches. But I've kept the third switch because I actually need more than 48 ports. I technically don't use every single one of them because I have about 3 dozen ports all throughout my house in different places where I technically don't have something plugged into them, but I like having all my wall jacks and everything connected to my network switches, so I don't have to like juggle cables around and mess with that if I need to light up a new port for some reason, if I want to plug a new device in. I always have enough capacity for every device that I could plug in, that I ever would want to plug into my network. When I was first looking at 48 port switches, I was looking at non-PoE versions because some of the even gigabit ones were very expensive. And so I found like a MochaLink switch that was like 48 ports. It had 6 FFP plus interfaces on, which I thought was great because a lot of them only have 4 SFP plus interfaces. Then I realized Grandstream also has a 48 port switch that's PoE and a non-PoE version that has 6 SFP plus interfaces on it. They had the PoE version on sale, so at this one site, it's not Amazon, and it was almost like $180 off or whatever. It was brand new, so it wasn't used or anything. So I decided to pull the trigger on that one, even though it was a little more expensive than if I would have got the MochaLink or even the Grandstream non-PoE version. However, it's actually still cheaper than a TP-Link 48-port switch that was not PoE. So it's actually cheaper than that, and I have PoE. They have a really nice web interface, and it works really well and stuff. So I thought I'd give it a shot to try out their PoE switch. So I'm excited to actually open this up and check out what's inside this box here. As you can see, the box is kind of big because it's a 48-port switch. And PoE switches, I noticed, are probably a little bit deeper and bigger because they have to have all the power distribution and that kind of stuff. Here's this. Comes with all this stuff here. Power cable. Here's your ears, rack mount ears. And it looks like a little something for a cable tie there, which is kind of cool. And there's some screws for the rack ears. And look at this. It even comes with a little grounding cable here, so you can ground your switch to your rack, which is pretty cool. All right. There we go. All right, so here's the network switch. The moment we've been waiting for, right? Man, this thing is a beast. All right. Here we go. So I was trying to take a look at this because I haven't actually seen it myself. You're seeing it as I'm seeing it. So here it is in all of its glory. This thing is actually pretty significantly heavy. And I imagine it's for all the power distribution it has to be able to support. And as you can see, one of the things I really liked about it has 6 10 gig interfaces. So I can actually take advantage of 10 gig devices and interfaces, because right now I only have a couple devices directly connected to 10 gig, so I don't really have a good 10 gig setup yet. So I'm hoping this will be the beginning part of having a 10 gig network. It's got ports to the max on here, right? It's a maximum you can fit in a 19-inch rack mount, pretty much, right? So even has room for a console port here as well, which is pretty crazy. They can fit 6 10 gig interfaces and 48 ports on here. So this thing, it feels like it's well made and constructed pretty well. So I'm actually pretty impressed so far as the build quality. So I actually recorded the first part of this video a little bit ago, and due to working on other projects and other videos and holidays and just taking a little break here and there, I didn't get around to finishing this video, but now I'm going to come back and add some additional pieces to my original video to make it more interesting, hopefully. But in the meantime, I've purchased a second Granstream switch that is also 48 port, but it's a non-PoE version. And as you can see, it still has the 6 10 gig SFP plus interfaces, which is one thing that I want because I like to have a little bit more than 6. You know, when I'm connecting these two switches together, I'm going to lose 2 interfaces. I really have 10 interfaces between the 2 switches. The side benefit of a 48 port switch is more of an OCD aesthetics type thing, but if you have a 24 port patch panel, you can plug the top row or bottom row of your switch directly in, and except that when you get towards the 10 gig interfaces, you have to stretch the cable a little bit, but it makes it nice and clean when you plug straight in from the patch panel when you have a 48 port. Because when you have a 24 port, it's all off the one side, and you have to stretch cables, across one side of your switch to the other. And one side is okay, but the other side of your patch panel is kind of stretched, right? So that's kind of a nice benefit. But I mostly did the extra $50 just to get the extra 10 gig interfaces. And because I decided to do these 2 switches to replace some of my old TP link switches, I don't need to get an aggregation switch right now. So I'm just kind of skipping 2.5 gig for the most part, and I'm just mostly going to be using 10 gig and 1 gig. But I have tested one RJ45 SFP Plus module to see if 2.5 gig would work, and that actually seemed to work pretty well because for a short while I actually had my TrueNAS box set up with this because I was getting the full throughput when I was transferring stuff to my TrueNAS box. So that's pretty cool that even though this switch isn't advertised to work at 2.5 gigs, it seems like the module was converting those data rate. So that's pretty cool. That's a possibility. If you have a couple of 2.5 gig devices, you might be able to plug them into 10 gig in this network switch using those RJ45 to SFP Plus modules. One thing that I thought was kind of interesting is with my TrueNAS system, I actually have a 10 gig SFP Plus NIC in it, and it wouldn't negotiate with the switch properly with a passive DAC cable that I was using. And I fiddled around with it. I tried 2 different brands of DAC cables. I tried 2 different even NICs, SFP Plus NICs, and neither one of those would work with the switch. And I was like, this is very strange because I thought buying a new NIC would work or a new DAC cable. And I knew DAC cables can be finicky or whatever, but I never had any problems with any DAC cables really in the systems I've had. I had one brand that wouldn't really work well with the TP link switches at one point, and there's only one of the 2 or 3 cables that I've had of that brand. So I don't know if that cable was bad or whatever. So I got rid of that cable, so I don't have to worry about it anymore. But I never had a problem with it with connecting the devices up. And the interesting thing is, I actually had this NIC connected directly to my Proxmox server, which is a different brand NIC than that one with SFP Plus, and a direct connection would work. But connection to the Grandstream switch wouldn't work. So I thought maybe the Grandstream switch was picky. Maybe it is, maybe it isn't. But what I ended up finding out is that I had to go manually set the connection to be 10 gig. And not only that, Grandstream has an option to pick the length of DAC cable as well. And for some reason, when I set that in my options for Grandstream, it actually works without issue. So that was very strange to me that it only happened on my TrueNAS system. But that's just one thing I wanted to mention, that sometimes you might have to do something interesting like that if you run into an issue. So one nice thing about Grandstream switches is they have a built-in web interface or a web controller, whatever you want to call it, that you can manage each individual device directly. You don't have to adopt it into software like Unify, but they do have software that you can self-host a controller, but they call it the manager. GWN manager. So they have that. You can self-host it, or you can actually use their cloud version of their managed software. So you have options. You can log directly into the system, or you can self-host if you have multiple devices you want to manage, or you can use their cloud service. So that gives you lots of options on how you want to manage your devices. So what I'm going to do is I'm going to log into the PoE switch web interface. I'm not going to log into the non-PoE one because it's going to be exactly the same, except it won't have the PoE options, of course, because it doesn't need them. So I'm going to log into the Grandstream's web interface. So what I'm going to do is, since there's no DHCP server enabled on the switch by default, the network switch actually defaults to 192.168.0.254. So we need to make sure our computer is in the same network. Since there's no DHCP server, we just have to manually set our IP address. And I did that already, and I'll show you in the wired settings what I actually configured. So as soon as I get to it, as you can see, I made mine .10 in that same network, 192.168.0.10. So, and then you have to put a net mask in there, and this is the same as saying /24 in CIDR notation, but it's basically 255.255.255.0. You don't need a gateway since we're not connected to the internet. And basically that's all you need to do, and you should be able to connect to the network switch using the default IP address, which I mentioned earlier. Okay, when you get to the login page, the default username is admin, and then there, I forgot to mention this when I was unboxing the device, but you probably saw, if you look carefully in the video, I realized a little sticker fell out when I was pulling the network switch out, and it has the default password for your device. So you need to make sure you keep track of that. I actually took it off and stuck it to the back of my switch, so I'll always have it. But so if you factory reset it, you need to know what that is. So I'm going to type that in real quick. Okay, now that I typed that password in, it's going to have me change the password, which makes sense. Okay, now that we've changed the password, it's going to load into the interface. All right, so you can see some resource information about the device and its temperature and PoE usage. If you click on port info, you'll be able to see some information about each of the ports. I actually will have to scroll, maybe zoom out just one notch so you can see this on the web interface, but I actually have a 48 port switch with 6 SFP plus interfaces, so this fills up the screen pretty well. So if you have fewer ports, it'll fit easily. I just kind of zoomed out real quick. I'll zoom it back in so you can see a little bit better. So down below here is your basic port information, the speed you're connected at, and some statistics. It even includes how much power usage for each port. As you can see, if we go to the switching section, there are some different settings here for the basic port settings. You can see if it's enabled, if the link is up or down, if it's flow control, and these different types of things. So you can change the settings here on this operation page, so you can give it a description. It's nice. I like when switches give you a little place to put a description in or a name for that port, because you can actually label the devices that are on that port, which is really nice. I make use of that on all my switches, and I even make a separate little spreadsheet. I kind of track that a little bit, so I can just do a quick lookup without having to log into stuff. So it's not a bad idea to to put a little description, even if it changes every now and then. You just make it as part of your process, update the descriptions. I don't change stuff around too much on most of the devices to where it's a big problem to maintain that. So I just try to keep that up to date, and this is where you can enable jumbo frames or various flow controls. And then link aggregation is something you might want to make use of in your home network, especially for gigabit connections. If you don't have higher speed interfaces, adding a couple link aggregations for gigabit speeds might be helpful. You can take advantage of link aggregation pretty easily, but it's not really as necessary when you start getting to be 10 gigabits or higher, but you still can do it if you think you have some bottlenecks. So anyway, so we got MAC address tables. You can see all the MAC addresses, and then of course here's your VLAN configuration. Usually that's under your layer 2, which is your switching category section, and most switches will have it under here. So you can look at your port settings and your port members and those sorts of things. So you can look at your port settings, and if you look in here, it looks like everything defaults to trunk and accepts all frame types. PIV ID is 1. So it seems like some of the newer switches, like a lot of times, will default to trunk. Some of the other types of switches I noticed with TP-Link and like Cisco and those sorts of switches, they don't necessarily default to trunk. They might default to some kind of general mode or something, but you have to like manually set things to be trunk. So by default, it doesn't do that. A lot of the newer switches is make it easier for you. You don't have to do anything special if it's already chunked by default. Usually, you only need to change this if you want to assign this port, let's say, to a particular VLAN, which in that case you would just use access, right? And then you would set the PIV ID of your VLAN. So it's actually pretty simple to set a port to a specific VLAN, and all the other ports will just allow all the VLAN traffic through. So when you're connecting switches to your routers or firewalls and that sort of thing that are VLAN aware, all your VLAN traffic will go through. I'm planning to do a separate guide on how to do VLANs in a different video, so I'm not going to go over that in this video. Spanning tree is helpful if you want to avoid loops in your network and you have multiple switches connected together. I won't go into too much details on that. This is your IP address of your interfaces on your network switch. So a lot of network switches that are managed switches will allow you to set the IP address for each of your VLAN networks. So if you want to add, you can add additional interfaces to your different networks if you want to have this web interface visible on different networks. That's mostly what it's used for. So if you just want your management to be on a particular network, you can actually set it up here in your management VLAN if you have VLANs created. Most of the time you probably don't want to enable your web interface on other networks unless it's like your management VLAN, but you could set that here at the top. Instead of adding an additional interface down here, you could add it to multiple networks if you for some reason have multiple places where you want to manage this and you don't want to necessarily create firewall rules to allow that to happen, to go across networks. You can kind of keep all your traffic contained within a specific network. This is of course, there's DHCP settings. I'll click on them, but like most of the time you probably want your DHCP to be managed by a separate DHCP server on your network, or like through your router firewall, which is what I like to do. Just keep it all in the main box on your system for DHCP. So you could do DHCP server and DHCP relay as well. ARP table has your devices that are connected. This is my machine I'm connected from right now to manage the switch. And next is the multicast settings. If you want to use IGMP snooping, which is useful for multicast type traffic, if you have IPTVs or security cameras and that kind of thing, you could actually be a little more efficient with your bandwidth. Instead of broadcasting it to every interface, you could actually broadcast I think to specific interfaces on your network. So it definitely helps, I think, make things a little more efficient. I don't really make too much use of this really, because I kind of keep my cameras on their own network anyway. I don't have probably a ton of multicast traffic on my network, so I don't really notice like having any issues with bandwidth or throughput. But it's nice to have these options. Almost every managed switch has some sort of IGMP snooping settings. And there's also MLD snooping. It's kind of similar type concept here. I think it's just kind of some different protocols, different things you can do on the switch, which is nice to have that available. This routing section is for layer 3 information about, here's your routing table where you're going to go if you need to create maybe some static routes in here, possibly. Yeah, so there's some static routes in the next section here. So you can add a static route to a router. For some reason you don't have a direct connection to wherever your destination network is, you can put static routes in. Some people prefer to use dynamic routes instead, but for small networks it's probably easier just to configure a static route. Next up is the PoE section, and then if you see here on the global page, it tells you the total amount of power available in the system and how much is actually being used at the time. Okay, next up is the interface page, and you can see it tells you the max amount of power per interface, which is 30 watts. Security, storm control. It's got the security options and network switches are kind of interesting. You can do storm control. Got some port security. Port security is helpful if you want to limit the MAC addresses that are allowed on certain ports. That's more important probably for a corporate network, because on a home network, it's easier to control the devices that are on your network, unless you want certain ports that, like in different rooms where guests plug in, you could really limit that if you want. But it's just like a more maintenance than you might want to deal with a home network, but you can go for it if you want. Definitely an option there. It's available. Port isolation is something that I actually tried to experiment with a TP-Link switch at one point, and it's actually kind of nice, because if you want a device just only to connect to the internet, and you put it in a VLAN and you still have it separated from your other parts of your network, but within that VLAN, that device can still communicate with other devices in that VLAN. This is nice if you want to restrict access within a particular network in a way that doesn't require you to set up firewalls on each individual device. So it's another layer of protection you can do. You might not want to rely on that completely, but that's one way you can do it for devices that don't actually have a firewall directly built in and are wired into your network. I won't go through all these different ones here, because you can configure different things like radius and some different things in here if you want to use that as authentication server, DHCP snooping. There's different things in there you can mess with here for if you want to try to lock things down a little bit more. Let's go to the maintenance page. The first page on here is upgrade. So if you have a firmware upgrades, and it says this is the current version, there might be a newer version than this. I don't have it plugged into the internet yet, so I won't be able to know. I'm assuming, there's a check for updates button here, so you can actually directly connect to the internet to find updates. Let's look at diagnostics. So you can see here, there's some information you can ping and trace route and do some different things, port mirroring and testing out your fiber modules and copper. So those are kind of interesting. You say if you click on this, you can see if something's up or down. You should be able to test your cables and stuff out, or your links and different things. These are always kind of interesting diagnostics. There's a backup and restore page, so you can back up your configuration and restore it, which is helpful if so you don't have to redo everything. It's in here. I like that. If you like to use SNMP to monitor your network, so you can set it up here. There's Armon, for some monitoring of some statistics, kind of similar to the statistics page that we looked at earlier. And then there's some energy savings type stuff in here you can do. Let's go to system down here as the final menu. You got some basic settings in here that we can actually look at. Here's a device name. It defaults to China for the time zone, of course. And you can set your location, your system contact, set your NTP server. You can set that to your local network if you want, like if you're using OpenSense, for example. Reboot time, you can have it just scheduled reboots every so often, I guess. If you're having issues, you can just have it reboot. Access control, this is probably for the system itself, so you can set the timeout in minutes, and you can enable SSH or Telnet, which I don't know who uses Telnet these days. I would just use SSH. You got some remote access passwords you could set there. I hope you found this walkthrough of the Grandstream 48 port PoE switch to be helpful, so you can kind of see what the web interface looks like. It has like a nice clean interface. Seems like it's pretty easy to configure, and so I'm pretty pleased with it. The build quality feels heavy and solid and substantial. So until the next video, I hope you have a great day.